Okay, so this is our chapter number 6, which is center of gravity, and the content is the center of gravity and center of mass for a system of particles. Number 2, center of gravity and centroid for a body, and number 3 is composite bodies. This is the example of the applications of the center of gravity, where when we design the structure, as in figure, we need to know the center of gravity so that we can support the water tank. We can have the exact center of gravity, and we can design the lake or structure. Districts and their locations. So in this chapter, we will learn how to determine gravity. This is another application of center of gravity. One concern about the sport utility vehicle SUV is that it might tip over while taking a sharp turn. So if you have a corner road, so when we have guys, if you have any problem with my presentations, I mean with the line or whatsoever, just let me know. Because I'm using wireless actually, sorry. I just put in the LAN cable. No table. Okay, so when we have an SUV or we have a bus that taking a corner, so what do you bus concern? One of the important factors in determining its stability is the center of mass. Should it be higher or lower for making SUV more stable? Center of mass, is it better in height or lower in height? The center of mass. How do you determine its location? So we will discuss and learn how to calculate our center of gravity. Concept of the center of gravity and center of mass. The center of gravity, gravity G, we call it as CG, center of gravity, center of mass, or COG, center of gravity, also as the acronym. The center of gravity G is a point which locates the resultant weight of a system, either particles or body. So resultant weight, we have weight, we have mass, so the resultant weight at location. The sum of moments due to individual particle weight about any point is the same as the moment due to the resultant weight located at G. Okay. As you can see in the figure, for the figure above, try taking moments about A and about B. So we have let's say we take moment at point A from the figure, we have 4 Newton of weight, 4 Newton with 3 meter distance. It is acting at G. Okay, so if we have 4 Newton, then here 1 Newton is acting like that, and 3 Newton. If we take moment at A, so we have 4 Newton times 3, which is a negative 12 Newton meter, because it is clockwise direction, plus 3 Newton, this one, times 4 meter. So we have negative 12 Newton meter plus 12 Newton meter. So it is in equilibrium. It is the same answer if you take at moment at point B. Okay, if you have a moment at point B, we have negative 1 Newton times 4 meter plus 4 Newton counterclockwise times 1 meter equals to 0 in equilibrium. So it is actually about our weight and the reaction force. Okay, so our body is in equilibrium. Note that the sum of moments due to the individual particles' weights about point G is equals to 0 in equilibrium. Similarly, the center of mass is a point which locates the resultant mass of a system of particles or body. Generally, its location is the same as that of G. So, sama lah, di mana center of gravity tu, where is the center of gravity will react because of the body. So the support or the reaction, as we can see, 1 Newton and 3 Newton. If we add on for the Fy, so 1 plus 3, okay, this one 1 plus 3, and this is 4. So if it is in equilibrium, we have Fx equals to 0, Fy equals to 0, and moment equals to 0. So we need to find our center of gravity. Concept of centroid. The centroid C is a point which defines the geometric center. Geometric center. So if you have this rectangular, the geometric center of an object, the geometric center is for the height h, we divide it by 2. Okay, so we have centroid for h is half of the height. And for b, for the base, this is the line. So the intersection of x and y is the center of gravity. So concept of centroid is actually point for the geometry. So kalau ada line, if you have a line, then it is half of it. If you have a rectangle, or if you have a triangle, it is 1/3 of the height, and 1/3 of the base. Okay, so this is for triangle. The centroid coincides with the center of mass. So the coincides with the center of mass or the center of gravity only if the material is homogeneous. So this is our assumption. We assume that our body, our structure is in homogeneous. Okay. If an object has an axis of symmetry, then the centroid of object lies on that axis. So if it is symmetry, it is easy. If you have rectangle, it is at the center. If you have square, it is center. If you have circle, it is at the center. So easy. If you have the symmetrical shape, so it is actually at the center. But what if you have triangle, half circle, quarter? Okay, how to determine their center, the centroid? In some cases, the centroid is not located on the object. So it is not in the object. It is outside of the object. So center of gravity or center of mass for a system of particles. Consider a system of n particles. We have so many particles in our component. As shown in the figure, the net or the resultant weight is, this is resultant of weight. Summing the moments about the y-axis. So for the y-axis, we have x w, x1, w1, this is 1, this is 2, this is n. So we have x1, w1, x2, w2 bar, xn, and so all of the particles, okay, where x1 bar represents x coordinate of w. So x coordinate, this is the x bar 1 from x. Similarly, we can sum moments about x and z axis to find the coordinates of g. So we sum up of the y bar and z bar. So this is for x axis and z axis. So the location of our centroid in our centroid in x direction is x bar, where the summation of x times the weight divided by the summation of the weight. And it is the same method for y and also z. By replacing the w with m in this equation, the coordinates of the center of mass can be found. So this is the mass, it's the same mass, w over w. Okay. A rigid body can be considered as made up of an infinite number of particles. So there are so many particles. Hence, using the same principles as in the previous slide, we get the coordinates of G by simply replacing the discrete summation by the continuous summation. So here you come with the integration for the whole body. So integration is from 0 to what number? Okay. How tall, how thick, what is your height, width, and thickness. Thickness. Okay. So this is how you integrate to get the weight. So this is the integration, but we go fast for the integration, and you can have a look for the integration. We have here the equation is not so stable because I'm using PowerPoint in on the iPad, but I think I have uploaded the PDF version of our lecture slide, and you can have a look at the slides. Okay. Similarly, the coordinates before this we have W, which is a weight, mass. So we can obtain also the centroid for the volume, for the area, and for the length. Okay, if you have 50 meter length, so the center is here, 25. Okay, okay. Tak apa nanti saya terangkan. Okay, so ni integration. Kita tak perlu tengok ni. Okay, you can go through the examples. Okay, I will explain about the composite bodies. Composite is if we have so many shapes. So we have shapes, general shape, which is triangle, square, rectangle, circle. So as the this is shapes, and for the volume, we have pyramid, we have sphere, so forth and so on. We have cubic. So a composite bodies is the combination of those shapes and all volumes. So if it is about volume, so the volume will be combined to be together. So that makes it as composite bodies. Okay. Today's objective is to determine the location of the center of gravity, center of mass, or centroid using the method of composite bodies. So we are looking at the this method. Okay. A composite body in this section refers to a body made of a collection of simple shaped parts or wholes, a collection of complex shaped parts or wholes. So simple shape, which I have explained previously, we have triangle, square, rectangle, so simple shape rather than the complex shape. If you have a complex shape, you need to use the integration type to get the center of gravity. Okay. The composite method for determining the location of the center of gravity of a composite body requires simple arithmetic. Okay, if we have rectangle beam, okay, and we know that it is homogeneous, so the location of the center is at the center of the rectangle. It is same if we have square and circle. But what if we have okay? So this one, okay, this is actually we want to define. Okay, this is the beam, and you have look P, let's say, to the beam, and this is fixed on the wall. So we know that if we have a load and it is like that, the body will bend like that. Okay, and it is at the center. What we call is natural axis. But what if we have I beam as in the figure? Okay, I beam in the figure. So we have and we have load here. So the center, the natural axis, is not at the center for the whole height of the body. It is not at the center. So we need to find where is the center of gravity so that we can determine if we have like that. So this is the center. So we want to know the tensile up here and compression down here is up to what level? What level? The height of the compression. So we want to know the natural axis so that we can find our tension and compression sides of the body. The I-beam is commonly used in building structures. When doing a stress analysis on an I-beam, the location of the centroid is very important. How can we easily determine the location of the centroid for a given beam shape? Cars, SUVs, bikes, buses are assembled using many individual components. When designing for stability on the road, it is important to know that the location of the bike's center of gravity. So we need to know the center of gravity. If we know the weight and center of gravity of individual components, how can we determine the location of the center of gravity of the assembled unit? So from the figure, the center of gravity for the body is at number 3, the frame. Number 1 is the rear wheels. So this one, we have center number 1. Mechanical components, engine parts, cranking, piston, the whole engine is at number 2. Frame is at number 3. Front wheel is at number 4. So individual components, compartments have their individual center of gravity. So when we assemble, how do we determine their overall center of gravity. This is the definition of composite body. A series of connected simple shaped bodies, some kind like rectangular, triangular, semicircular. Such a body can be divided into its own composite parts, and provided the weight, location of center of gravity of each parts are known. So we can find the center of gravity for each part. The need of using integration method to determine the center of gravity of the entire composite body can be eliminated. So integration ni untuk simple shape. Okay. Based of the principle of center of gravity, this is for line. X bar is equals to X times lines divided by L. Y bar is equals to Y times L length divided by the summation. Okay. Throughout the all equation. So the summation of line, area, and volume, it is the same. For the above, X volume divided by volume, summation. So this one is you need to calculate. This is the centroid location. This table is going to be used when you have a question to find the center of gravity. So this is the centroid location. For the shape centroid location, for trapezoid, semi-parabolic, X-parabolic, parabolic, circular sector, quarter, semicircular, circular is at the center, hemisphere, cone, rectangular, triangular. Okay, so this is the centroid, the equation to find the centroid. Given the area as shown, find the centroid X bar and Y bar. So X bar, from X, this is X, this is Y. We need to find the centroid. So where is the centroid? Is it here? Is it here? So we need to find our centroid for the composite shapes. So for this shape, we have length, area, and volume. So for this type of question, we are using area. Okay? Because we can calculate the area. Follow the step for analysis. Sekejap, Divide the body into pieces that are known shapes. So we can divide it triangle, square, rectangle. Okay. So we can divide it We can divide it into 1, 2, and 3. Okay. Holes are considered as pieces with negative weight or size. So kalau holes negative, make a table with the first column for segment number, second column weight, mass or size, depending on the problem. This is table. Fix the coordinates. Determine the coordinates of the center of gravity of centroid of each piece, and then fill in the table. Okay, so ni step dia lah. Tapi it is very easy. So we have divided it into 3 parts. Okay, A, B, and C. Look at our X. Okay, X is at the bottom, X, and Y is here. Okay, now what do we have for our body? And then we look at every single shape, okay, every single shape, where is their centroid, okay? So we know that, let's have a look at C. C is here, okay? B is here. The centroid of the C and B. And finally, A is 1/3. That one. So what we have here is C, B, A. Then we look at A first. So we look at the area of A. What is the area of A? A is 1/2 times 3 times 3. The base and the height. So 9 divided by 2 is 4.5. So we have area for A is 4.5. Area for B, 3 times 2. So 6. Area for C, 1 times 1 area. So 1 meter square. This is the summation of A. Okay? And then we look at our X bar for each individual shape. Okay? This is our X, and we look at this is 0. Okay? This line is 0 for X. 0 for X. So from the first figure, figure A, so this is 1/3 of the whole length. So 1/3 times 3, which is 1. So X bar for A is 1. Next, we look at B. So we know that it is 2 meter, and then this area is 1 meter. Sorry, the length. The length of B in X direction is 1 meter. So we have 1 meter. But it is in the negative direction of X. So we have negative 1 meter. Next, for C, X for C, we know that the length of the base for C is 1 meter. So C is this one is 0.5. Okay, so this is 2 meter. So we need to add 2 times 2 at plus 0.5, which is 2.5 at the negative direction of x. That is x bar. We look at y bar. So this is the table that we have. A x bar, we have finished x bar. Now we look at the y bar. So y bar, we know that x is at the bottom. Okay, so we look at our first shape, which is A. A is 1/3. We know that this is the C. So y bar is 1 meter. B, y bar is 1.5 meter because we know it is the height of B is 3 meter and C it is 0.5. So we have 1, 1.5, 0.5. That is um, positive, positive y. So from the equation, ini equation, okay. So from the equation of area, we have summation of x bar times area divided by summation of area. Okay. So we need to calculate this one. Okay. So A times okay. A times x. Okay. So 4.5 times 1, we get 4.5. 6 times negative 1 is negative 6. 1 times negative 2.5, we have negative 2.5. So this is the summation. 4 plus negative 6 plus negative 2.5, we get negative 4. And then we need to find our A y bar. A times y bar. 4.5 times 1 equals to 4.5. 6 times 1.5 equals to 9. And 1 times 0.5 equals to 0.5. And the summation 4.5 plus 9 plus 0.5 is 14. So for our x bar will be sum of A x bar divided by summation of A. So summation of A x bar is negative 4. Summation of A is 11.5. So this will get our x bar. Total x bar for both of for the three shapes overall. Okay. Then we have y bar equals to summation of a y bar divided by a summation of a. So we have summation of a y bar is 14 divided by 11.5. So this is from what I've explained. So we get our x bar is negative 0.35. So that's mean negative 0.35 from here. This one is 1 meter. So negative 3.5, this is 5 here, this line. Okay. And y bar is 1.22 meter. So we have 1 meter here, 2 meter, 1.5, 1.2. So this is our centroid for the whole body. Okay. Okay. Now you have x and y, x and y here. Now I want you to make the table, okay, a x bar, y bar, a x bar, and a y bar. Okay, a y bar. And move your y here. Okay, move your y here. And you have um, a, b, c, a, x bar, y bar. And make the table like this. I want to know what is your answer for x bar and also y bar, but y bar is should be the same. Okay, try it now. So this is the figure. Okay. Okay, I pun buat, so you all semua kena buat, okay? Okay, dapat berapa jawapan dia? X bar dengan Y bar. Okay, siapa dapat berapa X bar? 2.65. Yang lain? 2.652. Y 1.217. $27.5. Vinesh, how come 27.5? Two point one six one six 2.167. Okay. Okay, for those yang tidur lagi, okay, yang tengah termenung, apa saya tanya? Okay, now we need to make up a table for our E, X, and Y bar. Okay, so first we need to divide our components into three components. So this is A, this is B, this is C. Because we move our Y bar. We move our Y. So we need to make up our table, and we have our A, B, and C. And this is our A, this is our X bar, this is our Y bar. This is our AX bar, this is our AY bar. And this is the summation that we need here, here, and here. Okay. Area of A, 1 times 1 is equals to 1 meter square. B, 2 times 3, 6 meter square. 2 times 3. So 6 meter square. C is 1 half of the base times the height. So 9 over 2. 9 divided by 2 is 4.5. X bar for our A. So because we have moved, so this is 0. And that one. Okay? So for A, X bar for A, we know that the X is 1 meter, so X bar is 0.5. We know that B is 2 meter, so the X bar is 1 meter from the rectangle plus 1 meter. So that is 2 meter. Okay? Kalau siapa, if you don't understand, please ask. Please ask, okay? And the centroid of the triangle, which is C, shape C, is 1/3 over the base, which is 1. So this is 1 plus another 3. So 3 meter plus 1 meter is equals to 4 meter. Okay, now ada soalan. Now we calculate our AX bar. So 1 times 0.5 is 0.5. 6 times 2 is 12. 4.5 times 4 is 9 times 2, 18. Okay. So the summation of AX bar is 12 plus 18 plus 0.5 is 30.5. Okay. Summation of A is 1 plus 6 plus 4.5 is 11.5. Y bar. Y bar should be the same from the from the same examples. So Y bar for A is, we know 1 meter, so Y bar is 0.5. The height if B is 3 meter divided by 2, 1.5. For triangle is 1/3 over the height. So it is 1 meter for Y bar. And then we calculate our AY bar. AY bar is 1 times 0.5 is 0.5. 6 times 1.5 is 9. 4.5 times 1 is 4.5. And we got the summation is 14. So for X bar, we have summation of AX bar divided by summation of A, 30.5 divided by 11.5. For Y bar, we have summation of AY bar divided by summation of A. We have 14 divided by 11.5. So this one 2.6522, 2.65. And the other one is 1.2174, call it 1.22 meter. So, from the previous marking, from the previous answer, okay, from the examples, it said that X bar equals to negative 0.2 0.35. Okay, so we have 0.35 and y bar equals to 1.22. So this is our centroid. So if we move the y here and we have x equals to 2.65, so 1, 2, 2.65. So this is 2.65 and this is 0.35. Okay, and the y bar is the same, 1.22. It should be the same centroid. So it is how you put your y. Okay, if you put your y here, you have all the positive answer. This is what I prefer. What I prefer, because I don't like the negative answer. I don't like the negative answer because it will confuse me. Okay, so I prefer to move my y to the first line of the shape. So I will have all positive answer for x and all positive answer for y, which is for me safer for me. Okay, because if we take this value, sometimes we put a wrong digit in calculator. We plus it all, so it will give a wrong answer to our solutions. Okay, so this is the examples. Tak payah group, individual boleh. It is very easy. Two blocks. So what we have here? What we have here? We have volume. Okay. When we have volume, we have x, y, and z. Okay. So we need to calculate x, y, and z direction. Two blocks of different materials are assembled as shown. Find the center of gravity of this assembly. Follow the steps for analysis. Sometimes and always you need to imagine. Okay, you need your imagination so that you can cut a through section. Okay, and let's say these questions, you have part A and part B, but sometimes there are somebody that cannot imagine, so they will have this body sometimes, but actually it has given. Sometimes you guys are thinking too complex sometimes, but the exact shape is this one. Okay, this is shape A. Okay, and the others at the back is shape B. So there are two shapes that you can divide into two, which is A and B. Okay, so there are two segments of A and B. So we have volume volume, so we need our X, Y, and Z. So now we have our volume. This is our volume. Before this, we have area. So we use area. So now we are using volume to calculate. Okay. What is the volume of A? A, volume of A is 1 over 2 times 2 times 6 times 6. Okay, so it is 36. Volume for B is 6 times 6 times 2. So it is 72. Okay, boleh eh? So that is our volume. And then we look at our X bar. We look at our X bar. So this is our X. So we need to look at our X bar. The first one is very easy. We have X for, for B is easy. We have X 2 centimeter, okay? And the length is 2 centimeter. Divide by 2 is 1. So we have 1. From Y lah kan, okay, from Y. So X bar for our component A is, this is the length of 6 cm. We know that it is, ada soalan ke? Okay, 1/3 of 6, which is 2 cm. So we have 2 cm here, plus by 2 cm from B. So we have 4 in X direction. So Y. So for Y, we look at our A. This is our Y. We look at our A. We know that length is 2 cm. So divide by 2, we get 1. And then we know that length of B is 6 cm. Divide by 2, we got 3 cm. Setengah. So every H, X, Y, and Z bar. Next, for Z. Okay, so Z, right? Z for B. We look at B. We have 6 cm. So divide by 2. We know that the centroid Z bar is 3. But for triangle, we know that it is 6 cm. It is 1/3 times 6 cm equals to 2. So this is our Z bar. So we calculate our V times X, 36 times 4, and 72 times 1. And then 36 times 1 Y bar, 72 times 3. And also for the Z bar. And this is the summation of Z, A, VZ bar, Vy bar, and Vx bar, divide by V. Okay. So what is the centroid? So the summation of x bar is summation of Vx bar divided by summation of V. Y bar summation of Vy bar divided by summation of V. Z bar summation of Vz bar divided by summation of V. So this one kita dapat 216, 252, 288. 216 over 108, 252 over 108, 288, 0108. So this is the answer for X bar, Y bar and Z bar. Okay. Okay, do it now. Given 3 blocks of different materials are assembled as shown. Find the center of gravity of this assembly. Follow the steps for analysis. So we need to find X bar equals to summation of Vx bar divided by V, Y bar, summation of Vy bar divided by V, Z is equals to summation of Vz bar divided by V. We can divide it into 3 components, which is 1, A, B, C. Okay. Okay, so please do it now. Boleh ke centroid? Apa soalan tu? Tan, boleh ke centroid tak dalam objek? Oh, boleh tak kalau center of gravity tu tak dalam? Boleh. Memang ada. Macam tadi yang saya bagi contoh, kalau dia line, circle, dia adalah beam tapi dia circle. Center of gravity kadang-kadang kat sini. Boleh berlaku. Okay, so we have A, B, and C. So calculate sebab yang ini kena perhatikan, the tricky is the trick in this question is how you use this one actually. This one, okay? So it really depends on if you take your component B like this and C like this, okay? It depends on how you take your components, or you take it as this one. So it depends. So another one is so dekat sini. Macam mana you ambil you punya component. Okay. or you can try it both. Okay, so try and you can get the answers. So for me, this is our end of chapter, which is center of gravity. And we don't have any specific tutorials about this, but you can try in from the textbooks. Okay, you can try from the textbooks, and you can uh, look at the examples and the problems or questions from the textbooks. Try to it is not avoid, but it is easy to when you have um, shapes, okay, simple shape like this, triangle, rectangle, square, and then you can divide it. This is a composite shape, okay. All right, so that's all for today. And we have our midterm on 8, okay, during class time using ulearn. So I hope that you get ready for the midterm, and I owe you solutions for, I think, chapter 4 or 5, tutorial 4. Okay, so we will look at it after the sem break, mid sem break. Okay, thank you everyone. See you in. It is not next week, after mid sem break. Okay, and on Tuesday we start our midterm on the class, during the class 10 to 12. Okay, that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. This one for the homework. Okay, I got this one. X is equals to X. This is my answer, but I didn't recheck it. Thank you very much. Uh, no, just you do the question. You don't have to upload in Ulen. Just try the homework. Okay. Okay. Thank you very much. Thank you. Bye bye.